Okay, this is question 3 in your SAC, and it was quite poorly done, so I'm going to do a video of it. We learnt in semester 1 that ethanol, or bioethanol, so this is relevant to unit 3 as well as what we're doing at the moment, because we're studying sugars. So this particular reaction with enzymes, which is what you have to put yeast if you're going to make bread, or pizza dough or something, or beer. You could get flour, so we're looking right at the moment at starch, which is a polymer of all of these glucose monomers. So we could extend this question and have starch in the flour with yeast with it, and the yeast have enzymes which will break up the polymer into its glucose monomer. And then it undergoes this fermentation reaction. So the glucose would be broken up into ethanol and carbon dioxide. And if you're making beer, you want the alcohol. And if you're making pizza dough or bread, then you want the flour to rise, so you want the carbon dioxide. This is a fermentation reaction, and you need to be able to write this balanced equation. So glucose making 2 ethanol and 2 carbon dioxide. So this is the way that we basically make alcohol, ethanol. In wine and spirits, we use some kind of sugar from like wine or potatoes, or wherever. So the different sorts of alcohol, the sugars come from different places, and then they have other molecules that give the different flavors for the alcohols. So whether you're making your polymers, your starch, from whatever source, potatoes, bread, wherever, turning it into sugars and then making your ethanol, or whether you're doing it to make carbon dioxide to make bread rise, we need to know fermentation reaction. So we've just done organic chemical reactions that you can do in the lab, although these things happen in nature as well. And normally, this is quite often a pathways kind of question where you'll have the little boxes, but I've set it up as a table, and I think that's throwing people. I just, when I cut and pasted the little symbol here, so there should be nothing in that box. So there's 2 other ways of making ethanol. Outline the last step in each pathway. So we're going to make ethanol. We want to know the reaction type and the name of the organic reactant. Organic means the carbon-containing reactant. So the chemical that you needed to make the ethanol in the last step. And then any other reactant that's not carbon-containing, and any little bits of help that you might have needed. So I'll just put up this. So you need to know these pathways, and no one has been bothering to learn them, I don't think. So if I make this a bit smaller, and we'll concentrate on the alcohol. Okay, so if we turn an alkane into a chloroalkane, we can turn it into an alcohol. So we've got our 2 carbon alcohol, ethanol. So the step before that, you would have to have a chloroalkane, chloroethane. Alright, so chloroethane. And then the step before that, you would have had ethane, sorry. So to go from ethane to chloroethane to ethanol, you're swapping or substituting the hydrogen here for a chlorine, using this, and then you're going to substitute or swap the chlorine for an OH to make your alcohol. So you need to know what chemicals, what other chemicals. You could have suggested sodium hydroxide. You could have just put a hydroxide. You need to make sure that you use the word hydroxide for this ion, and don't get that confused with hydroxyl for the functional group. Alright, so that's your other molecule. And this is the last step before it. So that could be the first one. And that doesn't need any extra help, because hydroxide is quite a strong oxidizing agent. So the whole pathway, you're being oxidized. These are oxidizing. It's oxidizing this. So the other way of making, so you see the two arrows, this is a classic kind of question because there's two different ways of making ethanol. So if we have a double bond, so we need two carbons, so ethene, this is our ethene. We can break one of those double bonds, put a hydrogen on one carbon and the OH on the other carbon and make ethanol. So we can react our ethene with water. Water is fairly weak at reacting and breaking these double bonds. The electrons here aren't really that attracted to the water molecule, so it needs a bit of energy to help break these bonds to overcome the activation energy, so you need to heat it, and you also need a catalyst. So the phosphoric acid is acting like a catalyst. The hydrogen ions, H plus ions, would be attracting those electrons, making that bond break, and then you would form a bond with the hydrogen, and you'd have a free radical here, so an unpaired electron which would attract this OH and make a bond here. I think that's how it works. So the phosphoric acid is used as a catalyst to help break these bonds. So this, you're just adding two molecules together, ethene and water, and you're not making anything else, so it's an addition reaction. Whereas this one, because we're swapping, so if you had sodium hydroxide, the chlorine is going to come off and the OH will go on, and then you've got sodium and chlorine, so you make another little molecule. You make sodium chloride as well, or potassium chloride, or you make some other little molecule apart from the ethanol. So you need to learn these pathways so you can apply them to questions. And this was very poorly done. I think part of the issue was that people didn't recognize that it was a pathway question. Even though I wrote the word pathway in here, I thought it would be simpler rather than writing a whole lot of boxes, just it's a substitution and it's an addition reaction, but apparently it wasn't. Okay, just to show you that it pops up quite often, this is last year's exam. Below is a reaction pathway beginning with hex 3ene. Hex has got 6 carbons, what am I saying? 6 carbons, hex is 6. And on the third one, 1, 2, 3, we have the double bond. Okay, between the 3 and the 4. Alright, so we're going to turn our hex 3ene into hex 3ol. So you can see this is that pathway that we're looking at. The addition, so the double bond, the alkene turning into alcohol. And obviously our poster, the poster that we've been using, is not going to be the same as what's on the exam. I can't, there's too many things, can't drag it up. So you need to recognize the steps no matter how it's drawn. So we're going to break the double bond and we're going to add water across it. So we need a water molecule, OH, a water molecule, and we're going to break the double bond and add water across. Okay, so break the double bond, break this bond, and form a bond here and a bond here. And then I make hex 3ol. The way I've drawn it, we would number it from here, 1, 2, 3. You always number whatever the main functional group is, you always number from the end to give it the lowest number. So I probably should have drawn my water molecule over the other side, but it doesn't matter. Okay, so hex 3ol. So the reagent that you need water, and you need phosphoric acid, and you need heat. Now the question, how does the question ask you to write the reagent? Does it give you information? State the reagents required to convert hex 3ene to hex 3ol in the box provided. So yeah, there's 3. You need water, you need phosphoric acid, and you need a bit of heat. Throw it all in there, if you know it all, throw it all in. I can't remember, I don't know what they wanted, but that's all the information that you need. We can break the double bond here. May as well do this question, the rest of it. What's the OU pack name? So make sure that you're not just writing, sometimes you need to draw pictures, sometimes you need to write the name, sometimes they ask you to do the semi-structural formula. So just make sure you're doing what they ask you to do. So it's not much point knowing how to draw this if you are asked to do the name of it. So we go back to our double bond. We have a double bond, and we're adding hydrogen bromide across it. So we're going to break the double bond and put the hydrogen on one, the bromine on the other. So you've got 1, 2, 3, 3 bromo, and it's not a hexene anymore, it's a hexane. 3 bromo hexane. If this was longer, may as well throw this idea in as well. If this was hep3ene, so 7 carbons, and you broke the double bond and put hydrogen bromide on it, then depending on which way around you positioned your hydrogen bromide, you could make 1, 2, 3, 4 a 4 bromo heptane, or you could make a 3 bromo heptane. So you would make some of each. Alright, so sometimes, even though technically addition reactions, you add one molecule to another molecule, you add them together and you get one product. So each time a reaction happens, you get one product. But sometimes you'll get different products because you've got, a different molecule. So you'll get 2 products. Not all at the same reaction time, obviously, but within the mixture. Okay.